Hello dear viewers, I am Khan Bahadur, Assistant Professor of Statistics, and you are watching a video from my YouTube channel Statistics by Khan. Dear viewers, I hope all of you will be doing great. Dear viewers, this YouTube channel Statistics by Khan has been created for basic statistics with a view to help the beginner students of statistics, the researchers of all fields, and other learners of basic statistics. I have also a Facebook page and group with the same name, Statistics by Khan. You can visit them for steps related to basic statistics. Dear viewers, for better understanding of concepts in my video, I would recommend you to watch the full video. After watching the full video, I assure you, you will understand the concepts very clearly. In today's lecture, we are computing median from continuous group data or from continuous frequency distribution. So let's start the lecture. Median from continuous group data or from continuous frequency distribution. So for the computation of median from continuous group data or from continuous frequency distribution, once again we are taking the same data set that has already been used for the computation of arithmetic mean and geometric mean from continuous group data or from continuous frequency distribution. So let's write the data set. Okay, so this is the data set and now we are computing median from this data set. So once again, as I have mentioned in the computation of median from discrete group data, that first of all we have to check whether the observations are in order or not. So in this case, the values of variable are given in forms of classes, not the individual or discrete values. So if we look at the classes, so they are already in order. So we don't need to arrange them because they are already in order. So the next step once again is that of the cumulative frequency. So we have already learned the computation of the cumulative frequencies in the computation of median in case of discrete group data or discrete frequency distribution. So let's compute the cumulative frequencies. As 9 is the first frequency, there is no preceding frequency, so we will write as it is. Then for 10 there is preceding frequency 9, so we will add these two, so it will give us 19. For 17 we will add the preceding frequencies with the 17 to get the cumulative frequency of this class, so this will become 36. And as I have told you that if we add with the cumulative frequency of the preceding class the class frequency of the succeeding class, so we will get the cumulative frequency for this succeeding class. That is, if we add with 36 this 10, so we will get the cumulative frequency for this class, which will become 46. Similarly, if we add with 46 the class frequency 5, so we will get the cumulative frequency for this class, so this will become 51. And similarly for this class, this will become 55. And for the final class, this will become 60. So these are the cumulative frequencies. And as I have told you that the last cumulative frequency must equal to the total of the frequencies. That is, summation f will also equal to 60. Because by construction they are equal. So if this final frequency is 60, so this must be 60. And we have already seen this total in the previous lectures, which is equal to 60. Now, as in the discrete frequency distribution, by definition, median is a value against half of the number of observations, but that is in the discrete form, when the values of the variable consist of discrete numbers. But over here now, the values of the variable are not discrete numbers, rather they are classes. So in this case, first of all, we will find the median class. So the median class can also be found by the same way. That is, a class against half of the total number of observations will be called as the median class. What do I mean? So this is what I meant. Median class is equal to size of n plus 1 divided by 2 in this th for the position in item. And as I have already told you in the last lecture that instead of n plus 1 we can simply use n. So n over 2 will also not be incorrect. Okay. Now, as I have also told you that this n is equal to summation f, because this n represents the total number of observations, and so is the case with summation f. So both of them are representing the same number, that is the total number of observations. So now in their formula we will put 60 for n, so this will become, after simplification we will get median class is equal to size of 30.5th item. Now we will consider this 31. After considering this 31 or 30, it doesn't matter at all. Now we will search this 31 in the cumulative frequencies. If there exists exact match between 31 and a value in the cumulative frequencies, so then the class against that cumulative frequency will be considered as the median class. On the other hand, if there doesn't exist exact match between this 31 and a value in the cumulative frequencies, So then we will take the next higher value to 31. So let's do that. First of all, we check for the exact match. So if we look at the cumulative frequency, so there is no exact match. Now the second option is there to take the next higher value to 31 in the cumulative frequencies. So 9 is smaller than 31, 19 is also smaller than 31, and 36 is the next higher value to 31. So we will take this and the class against this, so which is 104 to 124. So now this class is the median class. Now we have found the median class. But as there are infinite values and for median we need a single value, so now we will interpolate a single value in this class. Now as we are dealing with the median class, and these classes are corresponding to continuous group data or continuous frequency distribution. So by definition, in continuous group data or continuous frequency distribution, there should not be break in the values of the variable. So if we look at various classes, so there is gap between the two classes. That is, the upper limit of the previous class is not equal to the lower limit of the preceding class. So this is a gap. And by definition of continuous variable, there should not be any gap between the minimum value of the variable and the maximum value of the variable. In this case, the minimum value of the variable is 65 and the maximum value of the variable is 204. So there should not be any gap in between these two values. That is, the upper limit of the preceding class will equal to the lower limit of the succeeding class. The upper limit of the preceding class will be the lower limit of the succeeding class. Then such classes are called class boundaries. In class boundaries, the upper limit of the preceding class is also the lower limit of the succeeding class. What do I mean? The upper limit of the preceding class coincides with the lower limit of the succeeding class. For any class, the upper limit of this class must coincide with the lower limit of this class. And the same is the case for all of the classes. So now, these are class limits. In class limits, the upper limit of the preceding class does not equal to the lower limit of the succeeding class. So these are class limits, and what we are constructing now are called class boundaries. Okay, for class boundaries, as I have told you that the upper limit of the preceding class must equal to the lower limit of the succeeding class. It means they will be exactly the same values. Now for class boundaries, we will make them equal. So how can we make them equal? We will subtract this upper limit of the preceding class from the lower limit of the succeeding class. That is, we will subtract 84 from 85. 85 minus 84. And we'll divide this difference by 2. So it will give us 102 or 0.5. Okay, what I have done, I have subtracted this 84 from 85 and divided that difference by 2. So the difference became 1 and divided by 2, so I got 0.5. Now next I will subtract 104 from 105 and will divide that difference by 2. So again, if we look at the difference is 1 and if we divide it by 2, so we will get 0.5. And if we check for this class, I will subtract 124 from 125 and will divide that difference by 2. So the difference is 1, and if I divide it by 2, so I will get 0.5. And similarly, if you look at the rest of the classes, so in all of the classes, the upper limit of the preceding class is 1 less than the lower limit of the succeeding class. So I mean there is a constant difference of 1 between the consecutive classes. So for this purpose, I will use only 0.5 for all of the classes, because from such mechanism from all of the classes I will get 0.5. Okay, now what I will do with 0.5, I will subtract this 0.5 from the lower limit of the class and will add in the upper limit of the class. And we'll do the same for all of the classes. So if I do this with the first class, if I subtract 0.5 from 65, so I will get 64.5. And if I add 0.5 in 84, so I will get 84.5. Similarly, if I subtract 0.5 from 85, so I will get 84.5. In the same way, if I add 0.5 in 104, so I will get 104.5. Similarly, for the rest of the classes, if I subtract 0.5 from 105, so I will get 104.5. And if I add 0.5 in 124, so it will become 124.5. And similarly, keeping the same procedure for all of the classes, we will get. So these are now class boundaries, because there is match between the upper limit of the preceding class with the lower limit of the succeeding class. And we can see this relation throughout in the classes. Okay, now instead of this class, we will consider this class. That is, instead of these class limits, we will consider class boundaries, because it fulfills the definition of continuous variable, as there is no gap between the minimum possible value of the variable and the maximum possible value of the variable. So now this is a continuous variable. So now this exactly matches to the definition of continuous variable. Now we will interpolate the median in this class. So for the interpolation of the median, we will use this formula. Now this is the formula for the interpolation of the median. Sorry, I forgot to write median over here. This is median class. But as I have told you that now we will consider this, so now this is the median class. Okay, what is L? L is the lower limit of the median class. So now as we have considered this is the median class, so 104.5 is L. So 104.5 is L plus. What is I? I is the interval. So interval throughout is 20. But actually we are concerned with the interval of the median class. So the interval of the median class is 20. What is F? F is the median class frequency. So this is median class and these are two frequencies. But don't remember, this is absolute frequency and this is cumulative frequency. But this F stands for the absolute frequency, not for the cumulative frequency. So not to be confused in these two frequencies. For F, we will put 17, the class frequency. No cumulative frequency, class frequency, simple frequency or absolute frequency. Okay, N is usual the total number of observations. So the total number of observations is 60 divided by 2 minus cumulative frequency. This cumulative frequency is of the preceding class to the median class. This is the preceding class for this median class. This is the median class and this is the preceding class. So the cumulative frequency of this 10 is the absolute frequency of this class and this 19 is the cumulative frequency of this class. Over here it was absolute frequency, but over here this is the cumulative frequency but of the preceding class. So the cumulative frequency for this class would be 19. Next it would become, and after simplification we will get 117 point something. So this is the answer and this is the median. Median is equal to 117.5 approximately. We have interpolated the value of the median which became 117.5. Now there is a rough check. If this value is lying outside this class, that is if this value is smaller than the smaller class boundary of the median class, or if this value is greater than the upper class boundary of the median class. If it lies outside this class, so then definitely the answer will be incorrect. But if it lies inside this class, so you may say that the answer may be correct. But if it lies outside this class, so definitely for sure the answer is incorrect. So this is a rough check. Now one thing you might have been taught that while computing arithmetic mean, geometric mean or harmonic mean from continuous group data, we haven't constructed class boundaries. And over here we have constructed class boundaries. So the reason for this is that while computing arithmetic mean, geometric mean or harmonic mean from continuous group data, we haven't used the classes themselves. Rather, we have computed x from these classes. And if we compute x from these class limits or from class boundaries, we will get identical results. So that is why we don't need to construct class boundaries for the computation of arithmetic mean, geometric mean or harmonic mean. But whenever we are using the classes themselves in the computation of any measure, so then in that case we will have to transform class limits into class boundaries. So now as in the final formula of the median, we were using one of the limits of the median class. So for that purpose we have transformed the class limits into class boundaries. So this is very much important example because the steps that are taken in this example are very much related to the example that are to come. We will discuss that as well. So that is why focus to learn these steps because they are very useful and will be used in future. So this was all about the computation of median from continuous group data or from continuous frequency distribution. Hope this will help you in the computation of median from continuous group data or from continuous frequency distribution. Thank you for watching the video.